Sustainable design, thinking about the model. We already presented the model for sustainable design. Here I probably should have written environmentally sustainable design. We'll introduce the idea of traps, trade-offs, and triumphs as a way of thinking about environmentally sustainable design. And then we'll talk about sustainable design processes that might be successful, say, in an organizational or industrial kind of a context. Okay? So that's where we'll start. And I'll just take us through very quickly slides we looked at on the first day. So you'll remember some of the motivation here, population, affluence, and we call this a technology term. We say that really as population goes up, affluence goes up, we can modulate environmental impacts by not only having technology available. That's what the life cycle design does. It's technology or solutions that reduce environmental impact. We also said it's not just about the technology, it's about the extent to which that's deployed, right? So that's where the environmental sustainability and the economics component comes in. So we talked about our motto of life cycle assessment, and you might remember we talked about this aluminum intensive vehicle and the use of a life cycle assessment to judge whether we were going to get our greenhouse gas emissions that we have to increase in production back during the use phase. And we talked about the supply chain for aluminum and how where you get the aluminum from might determine the payback period, meaning how long it takes to get, how long you have to drive that car around to actually offset the production emissions to make this solution work out better in terms of the environment. So we're looking at CO2 equivalents, greenhouse gas emissions here, and their reductions over time. Okay. So life cycle assessment does this kind of thing. Life cycle design would suggest that this is a pretty good idea. Right? You win in the end, at least from the greenhouse gas perspective, and you do mostly from the others too. But remember, there are questions that the LCA doesn't answer, right? Will people buy those cars, and if they do, or would they buy them, and would producers make the vehicles? And if they did, then where would that aluminum come from? Would the supply chain somehow adjust? Maybe the price of the aluminum would go up, forcing the production somewhere else where there may be higher or lower emissions factors, and might these economic effects ultimately thwart that aluminum-intensive vehicle approach, right? So we proposed a different model for sustainable design, or at least environmentally sustainable design, over here, where we brought the economics factors in, we brought the technology options in, we brought the policy in, and we looked at these life cycle emissions. It's not that life cycle assessment disappears when we do the sustainability assessment, but we just recognize that those life cycle emissions are consequences of economic decisions. Okay, so that's the basic difference. Okay, so life cycle design is very useful really in two ways. One is sort of thinking obviously about the consequences throughout the supply chain, but also as a means to inspire new technology. So let's think about maybe if we're concerned about we got an electric car and we're concerned about nickel metal hydride batteries, maybe we go to some other technology. If we're concerned about where the lithium is going to come from eventually, and there's a big controversy about that, maybe we think of something else. So it can be a source of innovation also. The life cycle design strategies wheel is sort of a way that forces designers to think about all the aspects of a product. So let's think about what the product actually is. So about 2 years ago, my calculator broke, and this is looking to see. I just couldn't bring it to myself to. I needed a calculator to have on my desk, and the computer's inconvenient, to make calculations. So I actually didn't buy one. It wasn't really a financial issue. I just felt like it wasn't the right thing to do. So I was borrowing calculators from people for about 2 years. But then I realized that, there's an app for that, and I do have an iPod Touch. So I got my favorite calculator from grade school on my iPod Touch. And that's the idea that maybe you can combine functions or think about another way to provide service. How many people have owned an answering machine? Yeah, I'm there too. So that that number is going to keep shrinking over time, naturally. How many people don't know what an answering machine is? Okay, all right. So that's still a joke. I mean, when it's a blank stare, that's when you know you're old. So I know I'm old. All right. So we rethink the idea of an answering machine. What do you need an answering machine for? You got voicemail, right? So combining functions. Thinking about using low impact materials. So in the case of the aluminum intensive vehicle, aluminum is not a low impact material relative to an equivalent sort of steel vehicle, right? Now, it may have benefits in other parts of the life cycle, but we're thinking here about low impact materials, reused materials, recycled materials. How much material are you using at the product and component level? How are you manufacturing the product? Is it energy intensive? Is it not? Can you remanufacture and take old components and make them components of new products? Distribution systems. We won't talk a whole lot about distribution systems other than to say, well, no, I think it might come up next week actually, but the idea that urgency usually leads to environmental impact. So the slower you go, typically the lower the impacts for somewhat obvious reasons. The impact during use, and that's something that's kind of obvious to think about, but maybe not, right? If I'm a maker of inkjet printers and I have an incentive to sell ink, maybe I'm going to try to burn through as many cartridges as I can, unless I think about some kind of a collection system. And for laser toner cartridges, that that practice is not uncommon. How long is a product going to last? Can it be reused? What's going to happen to it at the product system level? A lot of times designers aren't necessarily thinking about the end of life, right? So this is fairly intuitive, right? Go around the lids wheel and think about options. And you can even do this qualitatively, right? You could say, all right, if better means on the outside of the ring, then maybe if I want to compare two designs, am I doing better or worse? Here's design A, here's design B, and if you're doing better in all the components, it's probably a better design as a life cycle design. I'm not saying that you'd sell that product, but it might be a better life cycle design. Right? To Siddharth's point, usually you don't get something this clean. It might be worse in one dimension and better in another, and you gotta make some trade-offs there. Lids wheel, makes sense? Not going to belabor this too much. It's a lot more fun to talk about. Okay, let's have a lecture on material selection and just go through that. So we'll start doing that next week. So one of the best 589 projects ever was done last year by Christina, Lindsay, and Arthur. And they made a video podcast. They called it Sustainable Design for Designers. And they did the lids wheel better than I ever could. It's amazing. And they've got the broader sustainability elements in here too. But I bring it up now because I'll throw up some links. I think this is worth checking out. I mean, if people are sort of serious about design, doing design, this is about, if I remember, it's about 45 to 60 minutes, something like that. Just really interesting and witty. Video podcasting going on, educational in its intent. And there's a set of PowerPoint slides that go along with it. So I'm going to make that available to you. So, and look at the graphics, right? Just beautiful. So, basically the same, going around the wheel. But on this particular PowerPoint slide, which I'll provide to you, you can click on the links and, maybe it's 5 to 10 minutes on each of those. Okay. And I'll talk about each of these for a couple of minutes here too. But this one's definitely comes on the highly recommended list. These are just the links. And, I had some of my own slides on the lids wheel. And so that's reading number 34. So some additional examples. But, actually Scott, he's at the University of Pennsylvania, Millersville there. He had better slides than I had, more concise. So I pilfered his slides on this. So this is just, taking a designer's perspective now. Designing with innovation, low impact materials, optimized manufacturing, efficient distribution, low impact use, optimizing the product lifetime, optimizing the end of life. Okay, these are the actions of the LIDS wheel. And then just some thoughts on each of those steps. So designing with innovation, right? Rethinking how to provide the benefit. This is Velcro. Products as services is one potential model. We mentioned the idea of a fax machine. If you didn't want to own a fax machine, you'd rather just sort of rent it. And then if you need a new function because you're running a business, something like that, you just sort of swap it out. You could think about that model for phones, and we want to own our phones, but we all change them out. Maybe there's a service model there that would give the producers some incentive as they collect back their old phones to then reuse the components, and recognizing the stylistic and functional obsolescence being an issue that they could overcome. Go ahead.
Where is the element of cost coming in the previous slide? I mean, when you design, you have to design for cost.
This is life cycle design, man. That's sustainability stuff, right? The idea here is, let's design for the life cycle. Now, you could say life cycle cost, but ultimately you're getting into the economics. And the Venn diagram that brings economics and environment together, that's sustainable design, right? So I'm trying to make a case that they're different things. At this stage, you're not thinking about cost. You're coming up with ideas. Is that clear? I'm not sure what using living organisms in the product does, but it would be cool, right? The only one I could think about was like yogurt. I don't know, maybe there's, or those shrimp you get in the glass, whatever, bubble things that you. Anyway, anybody come up with another? Good. What's it?
Animal testing?
That's not the product.
Wastewater treatment plants that are based off of.
Yeah, so wastewater treatment plants, they're more like operations than products. I think consumer here. Go ahead.
They have that new packaging material that's based mushroom-based. So it grows. They're basically growing a packaging material.
So they grow in the packaging material. So that's good. I think the idea here is that the organisms are actually living in the product. They use living organisms. They're not once alive organisms. So that, I don't know. I think more people think about that. Got the design guy, so who knows. So thinking about low impact materials, obviously renewable materials, waste byproducts. He talks about using thoroughly tested materials. I think that's a good idea because quality, when things break, materials that don't last long, materials that are sort of fashionable, but just fashionable for a period. So you can think about thoroughly tested from a physical material, mechanical point of view. You can think about that from the standpoint of sort of audience tested. Recycled, reused. Obviously, you don't want to hurt people. Manufacturing techniques, again, talking about quality control, minimizing defects, minimizing waste, minimizing energy, minimizing the number of steps, which generally, all of these are just rules of thumb, right? You can imagine there's certain things you can do to reduce the number of steps, but maybe you increase energy. So, we need to be thinking about trade-offs here too. Minimizing the number of components. Designing for efficient distribution, so reducing weight, size, nestable, sort of stacking. Here's a case where the packaging is the product. It's a light, kind of clever. Local production, minimizing the distances, transport distances. Low impact use of the product. I actually went to look this one up. This link is no longer active. So I was wondering, what they're doing here, if there's some kind of composting going on in terms of this portable lavatory there. But the idea is, minimizing water use, material use, energy use, minimizing emissions naturally. So these things are kind of obvious, right? Optimizing the product lifetimes, the durability, easy repair, easy upgrades. Designed for a second life with a different function. We'll talk about the seed phone later. It's something that's timeless, right? Designed for take-back programs. This group seems to be less into take-back programs than they were earlier in the week. Optimizing, so provide for recycling. Downcycling is better than no cycling, right? So if you think about that aluminum-intensive vehicle, and maybe that aluminum-intensive vehicle at the end of its life, maybe it's going to be an engine casting. That's obviously better than using virgin aluminums, which you probably would never do. Biodegradability, safe disposal, the kinds of things you might expect. Okay, going to end here. You got to think about trade-offs. This is the problem with life cycle design, is that this again I think comes back to Siddharth's point. We really need to understand these trade-offs, which is why we talk about some of the environmental science and emissions and ways of measuring emissions here in the class. If you extend the product life, you might reduce sales, as an example, right? You can reduce the number of operations in manufacturing, but you increase energy, right? And that's what designers do. They have to decide between trade-offs. But you obviously can't decide between trade-offs until you've established what those trade-offs are, right? So thinking about this. So, I don't want to be giving you a laundry list of stuff in class. We have our responsibility to say these things, so you know them, you've got them, we can test you on them. But much more I think useful is going to be examples. So last time we introduced the concept of life cycle design via the LIDS wheel, the Life Cycle Design Strategies wheel. Is anybody having enough of a memory from last week to remember what the idea of the LIDS wheel was? Share with us. Anyone willing to remind us of what that concept was about? We're going to dive in and talk about some of the complexities. Anyone? Come on. It was that hard? Come on, somebody give us a definition. It was a wheel. Go ahead, Matt.
Yeah, it was a wheel that was broken down into different disciplines, basically outlining the different segments of sustainable design and how if you design for one portion of the wheel, you'll be giving up something else or compromising in some other part of the wheel.
You could be, exactly. So basically a mnemonic or a way to think about a engineering decision, generally related to a product, but not necessarily. Thinking first at the system level about what this product is, what function is it trying to achieve, is there a better way to do it? We talked about answering machines and voicemail. We talked about materials, the choice of materials, as well as how much material. We talked about manufacturing methods and processes. We talked about distribution, use, end of life, disposal methods. So you add it all up, there's 7 or 8 different things to think about when you entertain the life cycle design strategies wheel. When we ended, we were just beginning to talk about some of the trade-offs, right? And most of the folks who teach eco-design or life cycle design, they will just say, well, here's the LIDS wheel, here's some examples, roll. For us, when we start thinking about the economic component and what might make sense from a business perspective, and we bring in the economic component, we recognize that if we're really trying to do the right thing, we might be making gains in one area, we might be sacrificing in another, and we should be thinking about those, right? So if you design something to be disassembled, depending on the fasteners you use, it might cost more and therefore be less profitable. And when you stop and think about, whether that design was actually required, there's regulation in Europe, of course, for producer responsibility where that disassembly may be required. Might make sense to actually do that from a profit perspective, but in other places it may not. Biodegradability could shorten life, could lower strength, so you might have more product coming out of that. So these are just some examples. If you design a cell phone that has less plastic in it, maybe it's not going to last as long. We know about the relative electronics footprint compared with the housing there. So we got to think about the trade-offs, and that's the basic message with the LIDS wheel. Everybody understand what the lids wheel is about? Is it coming back to you now? It's a pretty simple thing to keep in mind, right? Which is why we're not spending a whole lot of time on it. So the difference between a life cycle design and an environmentally sustainable design is about economics. So environmentally sustainable is 2 of the 3 legs of the triple bottom line. We talk about environment, we talk about economics. When we talk about economics, we talk about the incentive to perform sustainable design or have sustainable design activities as part of the corporate portfolio. We're talking about adding value. And it has to add enough value to make the activity worthwhile. So what I want to get across here is that sustainable design only works if it adds value. It's like any other aspect of a business, any other attributes or features of a product. So we can ask ourselves, if we're trying to evaluate whether a design is environmentally sustainable, we could ask ourselves about the form of value that sustainability is providing. Is it making positive value? Is it removing negative value? Right, that would be the same thing. If we're creating negative value for competitor firms, or like we talked about the slide rule, changing the system of values. That's a tough row to hoe. Maybe you can market a design enough to get people to buy it, but that's obviously a challenge. So basically 4 areas in which we can think about value creation. Under making positive value, we could talk about inspiring innovation, at a minimum. And we don't have to get into this question of whether, customers are willing to pay more. I mean, they may say that, but in reality, they may not. So that is an issue that we need to think about. Even if they're not willing to pay more, the idea of sustainable design activities requiring us to look at our products differently and thereby creating new ideas. And nobody's got a lock on innovation. There's some data to suggest from a manufacturing perspective that cleaner facilities thinking about sustainability, zero waste facilities are actually more productive facilities, and some of the hypotheses are out there that it is about morale, and people seem to feel good about being involved with protecting the environment as part of what they do. And as a result, some possibilities for increased productivity. So some work out there on that. The idea of developing new products without eroding old ones. We think about maybe cellular telephone remanufacturing. Maybe folks in this room don't necessarily have a remanufactured cell phone, but there are people in the world for which there's a market, and people making money are basically providing remanufactured cell phones to folks. So these are examples of making positive value. Removing negative value, this tends to be more the business as usual, right? So, worried about litigation, worried about fines. But, starting in the 90s, thinking about pollution prevention, this idea that we don't have to necessarily waste resources or pay somebody to haul off waste when, in fact, we could just eliminate the waste at the source, very similar to the idea of Six Sigma and Lean that many of you are familiar with. So removing negative value is positive for a company. So that is another area of value to think about. Creating negative value for competitor firms. So think back to the 80s when folks were figuring out that stratospheric ozone depletion was caused by CFCs. And you're a company that makes CFCs, so you are lobbying very hard to get people to ignore this problem until the day you figure out that, we can substitute CFCs with non-ozone depleting substances. And, you get a patent on that. Suddenly, we need to do something about the ozone depletion problem, right? And we need to go in hard and regulate, basically ban these CFCs, and now everybody has to buy my product. And there are other examples of creating negative value for competitor firms. The Prius, what that did for Toyota. When you think about what was actually going on in the early 2000s, at least here in the U.S., a car that came, from, the seeds of innovation and, put a very nice halo effect around Toyota, They didn't sell a ton of these at first, but in the same time as they're getting this green image, they're boosting up their SUV sales, and people didn't seem to notice what was really going on there. So the point is that the idea that Toyota is a tech green firm actually helped them out quite a bit. The reality was much more tempered. I'm not going to say it was negative necessarily, but you can certainly use sustainability as a strategy to create negative value for competitor firms. We're reading reports now. I read a popular press article now that the Chevy Volt's bringing people into GM dealers who never have stepped into a GM dealer, never would have considered buying a GM vehicle. And they're getting a fair amount of traffic. Obviously, the Chevy Volt itself is pretty expensive. So what's happening is people are coming into the showrooms and learning about the Volt. And here's a Chevy Cruze that's half the price almost, and gets very good fuel economy and basically the same thing. And that vehicle is doing very well. So creating a halo effect around a nice piece of technology, and taking market share. GM's market share is actually going up now. I can't say it's just because of the Volt. There are other reasons too, but this is something, a way in which sustainability can have value. Going into, let's use our old slide rule from our first session. Saying this is a sustainable way to make calculations. This is environmentally very benign, low carbon footprint. It's great. It's made out of sustainable wood. It's biodegradable plastic. Doesn't require power except for human power. This is great. I'm going to sell you on a slide rule. I'm going to try to change your values. Say good luck with that, right? So this is a hard one, but it's something that we shouldn't rule out. And what I see more is that you see these sort of tech startups and green startups, and too often, the companies have sort of brainwashed themselves into thinking that the customers are going to think the way they do. They're going to get excited about the product in the same way they are, and people's values are somehow going to change when, in fact, the data is out there to suggest that they're really moving in a different direction. So this is up here more as a temper, as a caveat. Think about whether you're going against the tide or for the tide, because when we're talking about, again, environmental sustainability, it's got to be economically successful. Unless we're going to ban calculators, the government's going to do that. We're going to have a policy in place to, calculators are out, slide rules are in. We'll see what the illegal trade in, whatever calculator apps for your phone is or something like that. But you get the idea, hopefully. So value creation is the differentiator between life cycle design and sustainable design. You remember that park bench from last time, this extruded lawn waste that was sort of pressed into a chair you could put in your home. I just had it up there really quickly, and maybe a few of you didn't notice, or most of you didn't notice. But here's the most uncomfortable chair that anybody ever devised. It is biodegradable, but it's uncomfortable, right? So that's a gimmick, right? That's life cycle design. It's a good thing, but it's probably not going to be particularly sustainable. We think about the economic aspects. So just trying to create that differentiation for you. So with that in mind, I want to introduce the idea of traps, trade-offs, or triumphs. Okay? And let me, before I move forward in the presentation, just give you a verbal definition of what we mean by traps, trade-offs, and triumphs. So the idea of a trap is a product that is marketed as being a viable life cycle design, a product that will improve the overall environmental profile of that activity or that service or that functional unit. But it's not really environmentally conscious at all. Okay, so we would call that a trap. It's a product sold as green, it's not green. Trade-off would be the kinds of things we're talking about. A case where, it's really good in this dimension of the environment, it's not so good in this one. We got to make trade-offs. We talked about trade-offs in the context of unused pharmaceuticals disposal, right? That's a really good example. Or, the case where, this really is a green product, but it's not economically viable unless people change their values or some policy kicks in. Okay? A triumph is what we're after. It's that product that is green and everybody wants it. So that's a triumph, okay? And the thing about a triumph to notice is, to think about, is that these triumphs, you got to be a little bit careful with them. Because a triumph is usually something, because it's economically successful, there tends to be a lot of sales of those items. So if you replace item A with item B may have a lower footprint, but suddenly, people want 50 of them, and you might be worse off with B than A when you actually put the quantity into the picture. Now, I'm avoiding examples because your in-class exercise is to think of an example of a trap, a trade-off, and a triumph. Okay, so go ahead and take out a sheet of paper, any size or state, and list one of each. This is very quiet. Oh, it's because nobody's sitting next to their friends now, because we randomly, I'm not going to talk to the person next to me. I don't know this person. Go ahead. Absolutely. Just not so much when I'm trying to talk, if you don't mind. But I think Sam's got a good idea next to you. That's a cop-out, Lauren. It's true, though. It is true. It's totally true. Correct. Yeah, it's a big step forward in all the dimensions. Yeah. There will always be trade-offs. Well, that's the rub. So it's, a triumph in the end might not be a triumph when we start adding up how many of these are. Okay. So who's willing to volunteer a trap for us?
Ethanol fueled replacing fossil fuels.
Well, is that controversial? Who would agree? Ethanol. Corn-based ethanol. Everybody would agree. I would agree too, I think. I got a little graphic here. This is mine. That was my choice, Steve, so I think we're in agreement on that one. And with that. All right, corn-based ethanol. Go ahead.
You can now buy these like green bottled water bottles.
So can you explain what that is? Because it sounds like an oxymoron to me.
Great. So I guess there's some new type of plastic that's more environmentally friendly for the manufacturing of the bottle, but I feel like that's kind of a trap because what do you need a disposable water bottle for?
If we're talking about the same brand, what it is they just put half as much plastic in the bottle.
Okay, so would people think that a water, disposable water bottle or potentially recyclable water bottle that has half as much plastic, would that be a green bottle? Is that a trap? What do you think? Trap? All right. You know, it may be better than the alternative, right? I mean, if you're buying the water anyway, but the question of green and green marketing is a good one, right? If you can say this is green, well, you know, obviously maybe you shouldn't be using the product. There are a lot of water bottles out here, so I think people are familiar with the issues there. All right, so everybody understands the idea of a trap. So trade-offs are should be fairly obvious then too, hopefully. Trying to get my. How about an example of a trade-off? Go ahead.
Those chip bags that, those sun chips that came out.
Sun chips bag. Anybody check out that video yet? You're too busy with your homework. I'll give you an out. Yeah, check out that video. It's definitely, right, big time. So here's your compostable, sort of eco bag. Question number one was whether that's functionally compostable or not. Let's just assume it was. Then there's that whole noise thing and the fact that people started shying away from those sun chips. So definite trade-off, possible trap if that composting was really not effective. So that's just like shooting yourself in the foot twice because economically it didn't work and environmentally, but I don't actually know. I've heard stories about the composting thing. Anyone else on a trade-off? Go ahead.
Hydrogen fuel cells?
Hydrogen fuel cells. So why do you point to the hydrogen fuel cells?
Very environmentally friendly, but they cost too much money to be economically feasible.
And where are you going to get the hydrogen from?
Yes, that's true.
You know, if I decided to burn diesel to separate water, to transport hydrogen, losing half of it, you know, that wouldn't be a very good idea. So, yeah, certainly trade-offs on hydrogen done right today, and in the future, who knows. Okay, so trade-offs. I think you get the idea. We've talked a lot about it. I just put the original electric cars there. You know, this guy, he's trying to smile, but you know, he's a big guy, and it's a small car, and he's wondering where to put his golf clubs. I'm sure, you know, there. But no, those are some passionate owners there. Cost, obviously, an issue. Triumphs. This gets more interesting now. Who's bold to offer us a triumph? Go ahead.
Toyota Prius.
Toyota Prius. Triumph, let's vote. Everybody knows what a Prius is. Who votes for Triumph? Let's see. We're going to call that, what do we call it, 40%, Sarah?
35.
35. He is a human. All right. So we don't have a wide agreement with you. You want to defend the Prius?
I think Toyota did a pretty good job because they improved the efficiency of vehicles and reduced the fuel cost. So it was a triumph, although it was not really sustainable because they did not get the fuel like to zero, but it was a good effort towards sustainability.
Yeah, we're talking about moving in the right direction. Absolutely, less fuel was burned with respect to the people who bought those cars than the cars they would have otherwise bought. I think that's totally fair. Go ahead.
Can that be considered a trade-off though, because of the performance of the car isn't the same as?
Yeah, so that's why I think it's 35%, right? Because you can't go putting 5 people. Well, you can't put 5 people in there, but 5 people and golf clubs and some of the other things you might want to do. Or what's his top speed? Does anybody know?
Like 100.
Yeah, it's like 100. So you know that's not fast enough for me. But there's tastes involved too, right? It kind of looks goofy to some people because they go to school. Go ahead.
I wanted to give an example from the videos you sent out, the water bottle with the bleach. Would that be considered a triumph? I think it would.
The water bottle, which?
With the bleach that lights up.
The lighting, you mean,
Yeah.
the lighting system.
Yeah.
Yeah, I would call that a triumph, for sure. This is the idea where in developing countries where they may even have electricity, but they don't turn the lights on unless they have to because it's so expensive. So let's cut a hole in the roof, and we'll drop a soda bottle in there, a clear plastic one, and we'll put a little bleach in there so it doesn't get hazy, and it'll refract the light and light up the room, and also be sealed well enough so the rain doesn't come in. So nice idea there. It costs $1. It's cheaper than the electricity. Go ahead.
Interior trim of vehicles to be made from natural fibers instead of foam. Like there's new technology that supports it and says it's economically viable too.
So they're taking old waste foams, turning them into new foams. They're taking plastic bottles, turning them into carpet. So there's a lot of activity in that area that is completely functionally invisible, costs less, and reduces waste. So these are triumphs from the producer perspective. I don't think a customer is going to buy a car because of that. But a lot of material examples. I'll try to bring them in next time, actually. I have a few. Go ahead.
Does something have to be a product to be a triumph, or can it be a process as well?
Process for sure.
So, for example, when they charge you, like in the district at least, they charge you like
The
5
district.
cents.
This would be
Sorry.
which district?
The district, DC, Washington.
Which Washington. What do they charge you for?
They charge you, I think it's 10 cents for a plastic bag at the grocery store.
And you like being charged 10 cents?
No, but it's economically viable for people other than the customers, like for the grocery store, for example.
Yeah, and if policy's there that everybody kind of has to do this, and everybody's playing by the same rules, everybody goes out of business, and they solve the issues that they're trying to address. Steve?
Catalytic converters are pretty good.
They are, and I don't think anybody would go back on them now. Back in the day, let's go 100 years back when people thought, well, these safety regulations. Who read The Jungle by Upton Sinclair? Anyone? A few people? Okay, this is a book about the stockyards in Chicago and so the safety standards of the day and people getting hurt, what's ending up in your hot dogs, really not very pleasant stuff, but businesses were against that because of the cost. You can think about environmental add-ons to the vehicle like catalytic converters. I don't think today anybody would argue that safety regulations cost. I don't think anybody would talk about catalytic converters today. So we'll call that a triumph, probably saved thousands of lives invisibly. So I would certainly agree on that. Go ahead.
The refrigerant which is used in all refrigerators nowadays, R134A, after the CFC ban, it's one of the only good refrigerants that has a good COP and is environmentally friendly. So.
Is it a greenhouse gas?
Yes.
Yeah, but
Big time?
Yes.
Yeah.
So why is it a triumph?
Because it isn't. It has very, very, very low ozone depletion potential.
And what did it replace?
It replaced CFCs.
Which also are pretty big greenhouse gases. So this is actually, some people argue against some of the alternative refrigerants, and they point to the fact that they're greenhouse gases, but they don't point to the fact that what they replace were also potent greenhouse gases.
Greenhouse gases, they had very high CFCs.
Yeah, but the point I'm making is, I will not forget, because some of the reasons people are giving to not use them, at least before the regulations went into place, were that they have a high greenhouse gas potential. So yes, you're solving one problem, but we don't really want to switch because they cause this other problem. But the fact is the old system was also causing the same problem. So we can forget about it, but I think the history is important. I like to use computer screens as we, I got to kind of move on here, but these, who has a cathode ray tube on their desk? We got 1, 2, nice. So you're the ones, all right? Everybody else got these flat screens on there, which which use less energy. They do contain heavy metals, but not to the same extent, and everybody wants them. And I think who has a flat screen who would want to go back to a CRT? Anyone? Okay, I mean there could be some applications, I suppose. But the point there is, now you see 2 and 3 and 4, on people's desks, and I'm just as guilty as that as anyone else. So, the question is, how does 2, flat panel displays relative to a cathode ray tube monitor relate, or TVs, right? When TVs were cathode ray tube, right, they had the picture tube there, they could only really be so big for all practical purposes. But once they became flat screens, they could just get bigger and bigger and bigger and bigger. And so now people's expectations for TVs are different, and they're not a whole lot better if they are from old TVs. And there's some literature out there to suggest that they're worse now. So, these triumphs, we want triumphs, but we also want tempered triumphs. We don't want people to go crazy with triumphs. 6 computer screens, 8 computer screens. You get the idea. Okay, so when we talk about resolving the environmental trade-offs now, life cycle assessment is our ideal. It's objective, it's comprehensive, but it's a pain in the neck and it's expensive. So we might try to do things that are more subjective that don't require the money. But obviously this question of peer review, resolving trade-offs, these are questions. We could think about traps, trade-offs, and triumphs as a way to think about this somewhere in the middle. There are qualitative LCAs, which don't have the data requirements, but do have the questions of interpretation. They may be comprehensive in the same way, but certainly a lot more subjective. We could talk about ecological footprint. There are some chemical evaluation methods out there, but not widely used. So, as designers, if there were no trade-offs, there'd only be one design, and you wouldn't need designers. The whole idea of design is resolving trade-offs, and they exist in big ways when we talk about sustainability. So I want to be super clear because I find people who should be sustainability experts messing this up all the time. The difference between life cycle design, environmentally sustainable design, and sustainable design. So life cycle design is 1 circle. Environmentally sustainable design is 2 circles, so we bring the economic component in. And again, that's mostly what we're doing in this class, but like with the unused medications example, we bring the social component in. 3 circles, that's what sustainable design is, right? Society, environment, economics together. So we can't confuse these things. We bring money in, we're only, we start with life cycle design, we bring money in, then we've got environmentally sustainable design. When we bring the social component in on top of that, then we've got the full picture here. That's truly sustainable design.